Question 5. The amount of radioactive substance remains as it decays over time is A equals A sub 0 0.5 raised to the T over H power. A represents the final amount. Let me use my pen there just to underline that. A represents the final amount. A sub 0 represents, the original amount. So nothing new there. T represents the number of years. That's not new either. H represents the half-life of the substance. That's a little new. The half-life of the radioactive isotope carbon-14 is 5,730 years. So this is my H. We just said H represents the half-life. They're saying the half-life of the substance is this many years. I know it's not my T because, one, they tell me it's not, and two, look at the 4 answer choices. This shows us this is what we're trying to find. We're trying to find T in this problem. Approximately how many years will it take a 50-gram mass carbon-14 to decay 5? So the original amount is 50, is what we start with, and it's decaying to the final amount of 5 grams. So that's my A. This is my A sub 0. I'm going to take all those and insert them into this formula. So that's going to be 5 equals A sub 0 is 50 times 0.5 raised to the T power, which I do not know, over 5,730. Okay, so first off, I recognize this is almost exponential form. This is almost in this format right here. But it's not because we got this coefficient of 50 we need to get rid of first. So I'm going to divide both sides by 50. Those are going to cancel out. We're going to be left with, we can write this decimal because it terminates, it ends. It's not a decimal that keeps going on forever. So it's 0.1 equals 0.5 T to the 5 T over 5,730 power. That's a mouthful. Okay, so now at this point you might be thinking, okay, can we convert this to log form? The problem with that is, what's our base in this problem? What's the B in exponential form? It's 0.5. So if we convert this to log form, don't write this down, you'd end up getting log base 0.5. It's really hard to deal with bases that are not 10 when you're solving a problem. So instead what we're going to do, we're still going to use the logarithm. We have to, because there's no other way to solve this other than work it backwards. We're going to take the log of both sides and apply the exponential property, that third log property. I'll write it down here. So if you have log base b x raised to the n, you can rewrite it where that exponent of n now becomes the coefficient of the logarithm. So that's exactly what we're going to do. But before we can do that, we have to take the log of both sides. So we take the log of the right side, we take the log of the left side. So let's handle the right side first. Let's take this exponent and move it to the front of the coefficient slot there. So this becomes, let me switch to black, this becomes T over 5,730 times log 0.5. And keep in mind, by doing this, we have a base 10 in this problem, which is super helpful. On the left, we just got log of 0.1. We want to avoid putting in anything in the calculator at the very end. So next, to solve for t, we're going to divide both sides by log 0.5. Those are going to cancel. Divide this by log 0.5. I'm going to rewrite everything just so it's clear where we're at. So the left side, we've got log 0.1 divided by log 0.5. On the right side, we've got t divided by 5,730. So the final step to solve for t is we're going to multiply both sides by 5,730. It's going to cancel these out. And then all of this gets multiplied by 5,730. And I'll put this in the calculator all at once just to, again, risk a rounding error. So do log 0.1, enter. We get -1. Okay, so we didn't end up, we could have done that to begin with. Now we're going to take -1, we're going to divide it by the log of 0.5. Now we get a nasty decimal, and then finally we're going to multiply that by 5,730, and hope and pray that's one of our answer choices, 19,034. Let's look at that again. Did it round to 19,035? Yeah, 19,034.6. So it rounded up to 19,035.